I want to show you here how to use Excel to create graphs with your data. And I want to say a couple things about this before we begin, because I've been struggling with this some myself, trying to think about how to do this best. I feel a little guilty because I'd like to be able to give you a nice, clean, neat video that kind of went step 1, step 2, step 3, step 4, step 5, bingo, graph. And it's not like that. My real life is not like that. As at least as I've ever done statistics. It's a problem-solving process, and it's messy. I'm going to walk you through a set of data here. I'm going to show you how to take a set of data and work how I get from raw data to a graph. I'm going to walk you through the process of it. It's not going to be neat. It's not going to be orderly, because it often is not those sorts of things. It's often quite different than that. But I think it's a more realistic explanation of, like, this is how at least I do it, how I make sense of it. And you can figure out, well, Steve, I would have done this along the way first or whatever. But I'll show you some key steps along the way, some real benchmarks that are important in the process. The neat, clean part, if I had an editor and a production crew and all those sorts of things, maybe I'll do that easier. But it's not the way it actually happens usually. The way it usually happens is usually fairly messy. And I want to show you the messy process of it. So let me start with a data set. And you have a data set here of body temperatures. And there's a bunch of them here. And they go to, like, wow, there's 107 of them. Oops, nope. Since the title's up here, number 1, there's actually 106 of them. How would you go about making a graph of something like that? And let me get the other thing I want to mention here is the difference between, I make a distinction between a graph and a chart. For me, a chart is all numbers. A graph actually has some graphical figures in it, some geometric figure of some sort in it. That distinction is not clean in this field. Well, I make that distinction, or at least I try to. I'm not always good at it, because at some point I'll talk to you about a run chart. And a run chart's mostly a graph, but it's called a run chart. That's what everybody who calls it. So I'll use that language also. But I try to make a distinction between a chart and a graph, because charts tend to be just numbers. Graphs tend to have geometric figures in them of some sort, histograms or circles or pie charts or something. But when I start with a set of data like this, I mean, what do you do with this? Well, the first thing I do with it is I go, okay, let me take my lead thing here and go home and say, let's bold this up, turn it into a real thing. Let me take a format cells. And under alignment, I'm going to go to wrap text, which means that it puts different lines into a thing. And I'm going to spread this one out a little bit more. I may take this and I may take the whole column and say, let me center everything in the column. So it's a little bit easier, cleaner to look at in the process. Now I could try and just graph the values I have there, but this is raw data. And generally, raw data does not graph well. There's an exception to that, and I'll tell you the exception in a minute. But generally, if I said, okay, let me go here and say, if you note, I've highlighted the whole thing. Let me do a recommended chart. And it gives me something that looks like this as a scatter plot. And it's like, well, that doesn't exactly tell me much of anything. Or here's a line chart. And that doesn't really tell me anything, because supposedly the body temperatures are of different people. So this one here connects it up, and it's like, does person number 11 really come before person number 12? Or does it just happen to be that they got there first? Their temperature was taken first. This is graphing raw data. graphing raw data almost never works. And the one exception to this is when the data is time-based. When it's time-based data, you can graph the data and it makes some sense. If it's not time-based, it never makes any sense. So how would I start with this? One thing I would start with, I go to formulas, I go into statistical, and I'll do a thing called min. It asks me the range, and I'm saying, out of this range here, okay, there's all of them. What's the minimum? 96.5. Add a label to that. Go back to more functions, statistical. I'll come down and I'll pick out max. And I have to set the range for it. I want to say, what's the maximum coming down, there it is, the maximum of this range. So now I have max. So the temperatures in this data set range from a low of 96.5 to a high of 99.6. Another way of saying range would be is equals this high minus the low. It's a range of 3.1 degrees. Now, if I'm going to graph this, one of the things I want to do is I would like to probably put this into what they call bins or categories. So if I were going to develop categories for this, I might say, let's go from 96.5 to 97. So actually, because you want to have some difference in it, I would say 96.9. And then I might do 97.0 to 97.4. And then do from 97.5 to 98. Oops, nope, 97.9. One of the things I'm trying to do is make sure that my categories are all the same size. They're all at width of 0.4. So 98.0 to 98.4. 98.5 to 98.9. 99.0 to 99.4. And 95 to, oops, 99.5 to 99.9. So now I've created categories. And the question would be, how many would go in each of these categories? There's a way of checking that. But let me see if I can go back and do show you a quick way around this. I'm going to go to data and data analysis, and this thing called histogram. In histogram, my input range would be this bin range. I'm not sure how they want bin range exactly. So I'm going to try something and see if it'll accept it. Let me suggest my bin range might be this. Let's see what that does. And I have some choices here. I'm not going to add labels to it. I'm going to put my output range over here. Okay. And I'm going to do cumulative percentage and chart output. Let's see what that does. Bingo. Wow. Okay, what that just gave me. This is pretty exciting. I didn't realize it gets there quite there that easily. First of all, this thing here is, I said I wanted a chart. This right here is a chart. And not only is it a chart, is a cumulative frequency chart. And the range from 96.5 to 97, there's one, it says there's one value in that. From 97 to 97.5 says there's 4 values in this. It gives it a sense of what those things look like here. How many cases are in each thing. Let me just double check something here. I'm going to come back here, home, and I'm going to do a sum. 106. Okay, that's important because it means there are 106 cases, so I've actually got all my cases here. I didn't actually exclude anybody in the process. Trying to look at what I've got here. What's given me over here is an interesting piece. The blue lines here is a frequency distribution. It tells me the numbers. Let's see if I can. Stretch it out a little bit so make it a little clearer. The blue lines are the number of cases. This thing chart here, there's only one here under 97. There's 4 of them. Okay, that makes sense. 97.5, there's 12 of them. So it gives you a sense what the blue lines are what the frequency distribution looks like. The red line's a cumulative frequency distribution. It's this plus this. Each case at each place is this plus whatever came before it. And so that, in the chapter I have to do a thing I call about ogives. This is a sense of ogives, what an ogive would look like in this process. And this is here the percentages under that have been accumulated so far in the process. That was surprisingly easy. Let me go back and do this, go something a little bit different here. Let me come down here and say, let me insert a chart. Whoops. Let me do this. And down here's, and mark it and say, give me a chart. I don't want that kind of chart. Let me do this kind of chart. How about something that looks like this? I hope that calls for a series. Okay, let me come back to just recommended charts. Bang, here, let's take that one. Now, if you notice, this chart looks an awful lot like the blue charts here. It gives you the number of cases. The number of values are down here, the number of categories you have, and up here is vertically is the number of cases in each category. If you click on chart title, I'd say body temp distribution return, and that becomes, oops, put a capital there. I add a title to my chart. Um, this is a histogram chart. This one over here is a histogram with cumulative frequency distribution. Those are different kinds of charts that you may want to be looking at here. This one I made using the insert, and I went to recommended charts, and it gave me different. And I didn't give me that because I'm not telling you what kind of chart to use here, but it gives me different kinds of things. The data analysis piece, which I just gave some directions about how to get this added onto your computer. Under histogram, allowed me to do this one over here. It allows me, the big thing that it does for me is it helped me create, let's get this out of the way. This chart is, you can create a graph from a chart fairly easily, and it makes a lot more sense. If you try to create a graph from raw data, it will almost never make sense. Again, the one exception of that is when you have time-based data, that it really does make sense about what came first and what came second and so forth in the process. So that gives you a sense of how to do it, and it actually came out much easier, simpler than I thought it might be. Let me run through my steps here. First, I just reorganized this so it made some more sense to me. Second, I found the minimum and maximum, and I figured out what the range was. From there, what I decided was what were the categories, what size categories did I want? In my case, I've created 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I actually created 8 of them because one of them must be more than 99.5. Okay. Typically, this is a place of judgment for you. How many categories or bins, as the other language used here, that you have for your chart, that's a judgment issue. You could decide to use fewer. You could go down to 3, but 3 doesn't. If you use too few, your graph doesn't make a whole lot of sense because you've got too much condensed into it. If you say, oh, I want 27 categories, it helps some and it may be useful to you, but 27 feels too many to me. Generally, I shoot for somewhere around 7 to 11 categories. That's my general guideline for things about what I want to look for. Is one of those numbers right? Is 7 better than 9? Depends. Sometimes what I end up doing is I will go through and say, well, let me try it with 7 bins and see what that does. And I'll look at it and say, it's interesting. Now let's try it with 9 bins and see what that looks like. And so you end up playing with that to see what works best, because what you're doing with a graph, or what I'm trying to do with a graph, is that I'm trying to communicate information in graphic form. I can describe things to you. I can say the center of this is 27.3, or the range is this, and I give you a bunch of numbers, and those are all words. I can write stuff out, and those are all words. You see a graph, and it's like, oh, that's how that looks like it fits together. And it's a different way of communicating things, and sometimes it's a much more powerful way of communicating stuff. A good graph is really worth a whole lot. And one of the things I come back to I did here, after I created my graph, I created a title for it. You need to tell people what your graph is, what it's about. Down here, sometimes it's like what this says, it gives you a sense of what the reference numbers are for each of the pieces coming across, or each of the bins. 96.5 plus up to 97, up 97 up to 97.5, and so forth. It gives you some sense of what those things are. You need to include a certain amount of information in the graph for it to make sense. This week I give you some examples in the book of graphs that may look like they make sense, but they're really deceptive. And what I'm really trying to do, what I want to do is I want to communicate accurately what's going on in this data set. What does this look like? If you look at this data set, we think of normal temperature is 98.6. Well, normal temperature is right in here. What this says is you got some folks who are significantly lower than that. Their body temperature is running lower than that. Here, there's some who are running slightly higher than that, a few who are running a lot, not a lot higher, but a full degree higher than that. It gives you some sense of there's a range of it. I could tell you that the average, let me just do this for a second here, just to play it out differently. Let's come back to formula, average. The average temperature here is 98.2. So the average for this group is actually a little lower than we think of as what average people are, what the average human temperature is. The 98.2 tells you something that's a little low. What the graph tells you is it gives you a little bit clear, better sense of sort of the range of what's out there. And that's kind of information you're trying to use. You're trying to convey with the graph. You're trying to give people more information or a different way to process information than they would have if you just use words in the process. So that's how to create a histogram. There are choices within that. You have stacked histograms. You got to have at least two variables for. I mean, there's all kinds of stuff in there, and I really encourage you to go ahead and play with it and try some stuff out. I'm going to come up with another video, come up here and talk to you a little bit about pie charts. Now, truthfully, it's a pie graph, not a pie chart, but they're always called pie charts. What can I tell you? But it's going to, because you have a circle and you have a geographic figure, a geometric figure in it, I call it a graph as opposed to a chart. The chart is just the numbers. It's a certain number of categories with how many things are in each category. That's what a chart is. A graph for me is the same kind of information, but put in with some sort of geometric form to it that tends to convey different kinds of information or conveys the information somewhat differently. I'd like you to learn to do both of those things so you can create one of both of those. That's it for this one.